All right, so let's get started here. Full screen, get the old hat off. So what I'm deciding here is to share the worksheets that we work on in class so that everybody can take those worksheets home at night and see if they can work through the problems themselves. I'll try to keep the talk to a minimum because we're looking at about 35 problems that we're working on in class right now. And the hope is that if I can do this on a daily basis, that by the end of the semester, we will have gone through Algebra 1 up through a preliminary level of pre-cal, maybe even discuss some calculus concepts. If we do these problems repetitively, just a couple of minutes per problem a day, a minute here, a minute there, that over time it becomes working knowledge versus memorization for a test. So I put the problems already on the board. I'm going to go through them quickly because we have our conversations in class about the geometric, numerical, graphical, and analytic perspectives. So I'm not going to do that in any great detail here. This is just a check. Can you do the problems? Okay. And let's see where we're starting here. Over here. So yeah. So I guess I got to go this way with the camera. All right. So I'm looking at three operations. Order of operation doesn't matter. I see the 2, that's the square root of 4. The square root of 4 is 2. And I still have to do 2 to the minus 3, which is 1 over 2 cubed, which is 1/8. All right. And of course, I don't have an eraser, so I'll use my hat. All right. So now I've got 8 to the minus 2/3. Well, again, I think I'm going to do reciprocation last because this is 8 over 1. I'd rather work with 8 over 1 than 1 over 8. So I'm going to take the cube root of 8, the cube root of 8. Then I'm going to square it. And then I'm going to reciprocate it. Well, cube root of 8 is 2. 2 squared is 4. So 1/4. That's what you should get if you do this. Hey, 2 to the what equals 16. Talked about that the very first day. Logarithm means find the value of the exponent. Well, that's what this is. X is an exponent. What's the exponent you put on top of 2 to get 16? It's a 4. All right, so here we're going to go from quantity to exponent. And if I want to put it in exponential form, then 2 to the x equals 16. True. 2 to the 4 equals 16. All right, so let's continue on. All right, so what's this asking us to do? It's asking me to take the square root of 100. Means that machines worked better with numbers like this than radical symbols like that. So the answer is 10. What do I have to do to a 3 to turn it into a 1/9? I got to square it and I got to reciprocate. So my answer is -2. How do I get there? Well, I got to get the same base. That's 3 to the 2. And I know 1 over 3 squared is the same thing as 3 to the -2. All right, so what's the exponent? You put on top of 3 to get what's in the parentheses. There it is. That's the exponent. You put on top of 3 to get 1/9. I see I need a flip. If I flip this, I get 3/4. So I got to flip. That's the minus sign. Reciprocation. We talked about it in class. And how do I turn a 3 into a 27? I need to cube. And how do I turn a 4 into a 64? I need to cube. So 4/3 to the -3 flips and cubes, numerator and denominator, and I get this quantity. So there's your answer. All right, I hope this is going to be helpful. I am going through it quickly, but pause the video. Equation of a line. Well, we said the easiest way to write the equation of a line is 2 steps. Subtraction, -2 makes addition of 2, plus 3. I can see -2 in gets me a y value of 3, and -2 to 5 is a change of 7, and 3 to 11 is a change of 8. All right, and I guess this one is a sketch. So what can, or I think it was write 4 values. So we can write 4 values quickly. I can see a 3 makes a multiplication of 0. That's nice. And 2 goes into 0 nicely. That gives me a 7. And that should tell me that if I change and I change by 2, then my y value should go down 5. Well, there's 2, there's -3, and there's -8. 9 should get me -8. Let's find out if it's true. A y value of -8, does it come from a 9? Well, 9 minus 3 is 6. Yeah, I like 2 going into 6. That goes in easily. Goes 3 times, so I'm gonna drop down 5 3 times. 1, 2, 3. Oh, yeah. 2 goes into 6 3 times. Minus 15 plus 8, minus 15 plus 7, sorry to say. Oh, negative 8. By God, it worked. So now we're gonna graph number 8. Of course, I butchered it. See if I can get back from the table. That's a change of 2. I start with a 7. And so I gotta say x minus 3. And then we'll put it in everybody's favorite form, mx plus b. Unfortunately, I wish you never had that in your head to begin with. Okay, so let's get it into that mx plus b form, which I will soon be calling ax plus b. Soon, as in right now. Minus 5 halves x. Minus 5 times minus 3 is 15 over 2. Plus 7, I know what 7 is. It's 14 over 2. And I guess we have minus 5 halves x plus 19 over 2. There's your favorite form. It's not mine. Okay, let's get rid of that. No, I don't have to. I don't have to. Let's do the next problem. Let's sketch. What's the easiest way for you to sketch? Equation of a line, find 2 points. I can see minus 2 gets me 5. And my x changes by 3, so therefore a 1 should get me a nice number. 1 plus 2 is 3, the 3's cancel. Minus 4 plus 5 is 1. And I'll come over here and estimate minus 2, 5. And I'll estimate 1, 1. And I'll graph the line. I'm going to move the positive 6 to the other side because that's the graphing form I like. I like the ax minus h plus k graphing form. Because we're going to be working with hk and the quadratic and the cubic. All right, so can I see a couple of values here? And I can quickly, 4 gets me negative 6. And if I change my x's by 3, then a 7, I'm discriminatory in the positive direction. A 7 should get me changing my y value by up to negative 4. All right, so 4, negative 6, 4, negative 6 might be here. And 7, negative 4 is a little bit above it. There's my line. Done. Just plot those 2 points. All right, I haven't talked to you about eyes. Maybe I will in class today, but oh yeah. So if you square this thing, you should get 25 plus 10 double 20i plus 4i squared. And we're going to learn soon why I squared is negative 1. But at this stage, you're just hearing it for the first time from me, maybe. So that's negative 4. And so your final answer is 21 plus 20i. And that probably has no meaning for you at the moment. That's okay. We'll get to it. We just started a conversation. Minus 2/5 x minus 6. I have no idea what I asked in that equation. What might I have asked? No idea. Well, I still have it here, 13. Estimate graphically. Oh, equals 10. All right, so there's your favorite. Well, no, that's not mx plus b, but we can certainly see a 6 gets us a 0 on the left. Right? What's a 6 get us over here? Oh, it gets us a 10. Well, they're not equal. I can tell you one thing, 6 doesn't work. I can throw an 11 in here. 11 minus 6 is 5. The 5's cancel, so I can throw an 11 in. 11 gets me 5, and 5's cancel, and that gets me negative 2. And over here, an 11 gets me 10. Geez, doesn't seem like it matters if y equals 10 over here, and on the left, y equals minus 2/5, x minus 6, right? Well, these numbers don't work because they're not giving me the same y values, so they're not equal. Gee, it sure would be nice if I had a method for solving this. Well, how about I take division by 5 and multiply it over here? That would give me 50. And how about if I divide by negative 2? Well, that would give me negative 25. And how about if I add 6? Well, that would get me negative 19. Huh. So what number did I plug in to get that? I plugged in, I don't know what I'm doing right now. I'm solving for 10. Oh, it gets me 10. So negative 19 over here should get me 10. Negative 19 minus 6. Negative 19 minus 6 minus 25. How many times is 5 going to minus 25? Minus 5 times. And what's minus 2 times minus 5? 10. Oh, so if I put negative 19, is that what I put in there? If I put negative 19, I get 10. And I guess a constant, y equals 10. Y equals 10. When I put negative 19 into that function, I get 10. Oh, so negative 19 on the left and the right both get me 10. I think the x value that works here is negative 19. Maybe we could figure out graphically if that makes sense. So minus 2, this is such an important topic. X minus 6, I'm going to graph that. I can see that a 6 gets me 0. 6 gets me 0. 6 gets me 0. I can see that I'm going down 2 over 5. And it looks like I've got a decreasing function, and I want to know when it hits a height of 10. Well, here's a height of 10. Oh, boy, did I butcher that. I can't reach high enough. Here's 10. Here's 10. Oh my God. Does that x value look like it might be negative 19? If I drew it well enough, it should. All right. Be easier to get a graphical approximation for this one right here, because I'll be asking you to show it graphically. Minus 7x plus 5. Well, products equaling 0 is, I'm going to plug a 0 in. Makes that product real easy. 0 gets me 5. So now I have a ruler. That's 5 units worth of change. And minus 2x gets me 4. So that's pretty close. That's a height of 4. A 0 gets me 4 for the second line. I know I'm going down 7 over 1 from 5, down 7 over 1 here. So that line looks like that. I know this one's going down 2 over 1, down 2 over 1 gets me that. You know, I think my x value is pretty darn close to 0. Let's find it. I'm going to add 7x to this side. That gets me 2x. I'm going to take 4 away from that side. That gets me 1. Does it look like x equals a half might be where these intersect? I don't think I made any mistakes. The graph matches up with the algebra. I'm going to move on. All right. Let's see. 2x plus 5y equals 20. I'm going to solve that equation. Let's see. I know if I put a 0 in, y is 4. Oh, okay. I know if I put a 0 in for y, x is 10. I know if I put 20 in for x, that's 40, then y is negative 4. You know what? If I do it this way, I don't think I'm going to do anything for the rest of my life. I think there's an infinite number of numbers that I can come up with. Oh, Lord, what am I going to do? Why don't I graph the solution and show you every ordered pair that works? 0 gets you 4. 10 gets you 0. Looks like when I add a couple of things up and I get a constant, if this gets bigger, that better get smaller. Oops, I drove the wrong way. So looks like an ax plus by equals c is going down. I'll bet an ax minus by plus equals c is going up. Well, you might want to pay attention to that. So there's that. And there's an infinite number of places that work. And if I don't show all those solutions graphically, and I do it tabularly, that's the rest of my life. I think I'll show you the picture. Remember, 0, 4, 10, 0. And that's called the standard form of a line, standard form. And then, you know, when you have a graphing form, that means there's nothing you got to do. You should be able to work with it. That's the way it's written. You shouldn't have to change it. So for those of you trying to go to mx plus b, I'm sorry. I'm sorry you got brainwashed. 7x plus 3y equals 11. I think I'm trying to find the perpendicular. So I already know the answer, but let's have it go through AB. Is that what I'm supposed to do here? Maybe. I don't know if I asked for perpendicular, but you know, I know my answer is going to be 3/7 x minus a plus b. You know that just by looking at it, but let's prove it. Let's actually get, well, you remember what I said. let's actually get minus 7x plus 11 is on that side. Dividing by 3, get you your favorite, minus 7 over 3 plus x plus 11 thirds. Okay, if I want perpendicular, I know I need the reciprocal relationship. We've studied that in class. There's your 3/7, there's your x minus a plus b. All right, so that's what I'm hoping you get. Remember, the explanations are occurring at the board during class. So feel free to ask questions. X plus 6 times x minus 4. Well, you know, from your Algebra 1 days, you should know that's x squared minus 4x. 6x minus 24. And we've got ourselves x squared plus 2x minus 24. And products equaling 0 certainly get us information. So I know I got a quadratic up shape. I know -6 gets me a 0. And I know 4 gets me a 0. So it's helpful to put things in product form. And what's the number between -6 and 4? I believe it's -1. And if I put -1, I should get a fictitious square. So that's 5 and that's -5. Side lengths are the same magnitude, so I get -25 and I got a quick sketch. So factored form helps you get quick sketches. It's good to learn how to factor, how to write sums and differences as products. How would I write that as a product? First rule of writing products, take out what's common, which in this case is 5x. So I got to multiply by 3 and I got to get back to that, so I need 2x. Now they're the same. You put some numbers in, you'll see they're the same. Then your Algebra 1 skills, I hope, are in place already. So two numbers that multiply out to be 28 that are 12 apart, it's probably 2 and 14. Then I want a positive 12, so yes, so plus 14 times x minus 2. Got to learn those skills. X squared minus y squared, the difference of the square roots, x plus y, x minus y. Taking out what's common. Taking out what's common, I see 2 goes into 4n -6. I see x to the 1, take out the smaller exponent. Smaller exponent's 5, so take out what's common. How do I get back to this? Well, I got to double to get the 4. I've got 1x, I need 7, I need another 6. Why? The 5's already there. Here, I got to multiply by -3 to get back to -6. I already got the x, but I got 5 y's, I need 8, so I need another 3. Now, I've got to be able to do that. All right, so what have I got here? I think I probably got a cup shape down. 417, learning that that is the vertex and y we talked about in class. And I can throw a 0 in here. I know I got a minus, another minus times a positive. So I got a positive, so I'm going to be on the upside. Oh, I knew that anyway, right? 0's to the left of 4. And if I throw a 0 in, I've got myself 16, -48, -38, -31, I believe. All right, and that should be fine. Yeah, that's correct. All right. Oh my God, I hope I'm showing that. I barely did. I got to keep an eye on. I got to keep an eye on this camera here. Boy, I'm not doing this again because class starts soon. So I got a cup shape up. It's easier just to graph these things than it is to put them in graphing form. I know I'm on the decreasing side, so 0 gets me 7. Talk about it more in class. Certainly talk about it enough in different videos. I know minus b over 2a is that, so that makes sense, a positive 2. And if I put positive 2 in, minus 24, cut in half is minus 12 plus 7, gets me -5. And now I know my roots as well, but that's for another time. How do we write these? Well, we certainly can identify the most important point. X plus 3 squared minus 17. And I got minus 17 to 11, which is up 28 units. Is that right? My brain's getting a little tired. Up 28 units. And I know that the quadratic change from 3 to 9, from 3 to 0 is 9. So this is really run squared. And the run is 3 units, and you got a square. Then you can check your answer by plugging in 0 to see if you get 11. So if we put in 0, 0 plus 3, 3 squared, 9's cancel, 28 minus 17 gets you 11. We're getting there. All right, functional notation, all this is Algebra 1 review. Okay, but most students come in and they just haven't had enough practice with any of this stuff to have it be working knowledge. So let's put a 2 into the g function, and I get 4 minus 16 minus 20. So that's g of 2 is plugging in 2 for our x, which is something in Arabic. So we're gonna plug things in, and we're gonna, whatever we plug in, we're gonna evaluate, and I just threw a 2 in there, and that gets me minus 32. Okay, let's erase that. Y-intercepts. Well, if I throw 0 into g of 0 is equal to minus 20. Okay, so that's that y-intercept. This is not the y-intercept. I have to throw a 0 in. And so my y-intercept is 26 squared minus 3, which I'm not doing right now. Okay, there's an 8x minus 20. All right, so for your SATs, f of g of 1 could have been written as f of g of 1. That's a parentheses here. All right, so that means I'm going to plug g, I'm going to do g of 1. So if I plug 1 in here, I get 1 minus 8 minus 20, minus 28 plus 1 is minus 27. And then I got to plug that number into f. Well, that's not bad. Okay, I don't mind doing that one. Minus 27 plus 26, minus 1 squared is 1. 1 minus 3, negative 2. And that's called the composite. And you're going to work on this worksheet in class, and so hopefully you're going to get a lot of it done in class. Sketch f of x. Yeah, I can sketch f of x. It's cup shape up. The vertex is negative 26, negative 3. And if I put in negative 27, I get negative 2. So negative 27 is this way. I get negative 2. Now, you could also plug in negative 25. You should get the same answer. Okay, so there's your symmetry. All right, now it did ask for inverses. I'm not going to do the inverses because the inverse of this takes a little bit more of a discussion about what a function is. And so I'm going to leave that be. All right, you've got square root of 75. Should have done in Algebra 1. So that's 5 root 3. I'm giving you out a memorization sheet. I want you to know that root 3 is approximately 1.73 so that you can have a feeling for size. All right, now we're going to sketch 6 functions. I'm just going to do them quickly. Okay, hopefully you can see this. Positive multiplier, squaring, cup shape up. 5 gets me 7. You will never get a number less than 7 on this equation. And I will pick a number to the left. I like the y-intercept, so I'll put a 0 in. That gives me 25, 75 plus 7, 82. And if you want to know where the number 3 comes from, do rise over run squared with me as measured from the vertex. The rise from 7 to 82 is 75 units. The run from 5 to 0 is minus 5, but we're going to square that, which gets us 25. And that is indeed what that number is. 8x plus 2y equals 24, standard form. We just talked about it a half an hour ago. Plug in 0, cover it up. Y is 12. So if x is 0, y is 12. Cover up the y's. If y is 0, x is 3. So 3 gets me 0. 0 gets me 12. How many points does it take to graph the equation? Line 2. We're done. All right. Sketching. And one of your homeworks was to look at the video. How do you put quadratics in graphing form? So there we go. That gets us our first term. Minus b over 2a, minus 20 becomes 20 divided by 4 is 5, so minus 5. And I can check that real quick right now by plugging 5 in, and I better get a 2 to 1. 2 to 1 opposite relationship for the first 2 terms. So I plug 5 in, that gets me 50. Plug 5 in, minus 100. There's my opposite, 2 to 1. So no mistakes. I throw a 0 in, I should get 7. Right now, if I throw a 0 in, I get 50. I don't want that 50. I want 7. And there's your graphing form. And so minus 50 plus 7 is minus 43. All right, so cup shape up. I found the vertex, 5, negative 43. And I know that 0 is to the left of 5. I also know it's on the decreasing side. There it is, the minus side is coming down. And that 0 got me 7 because I can see it from the get-go. These are products. That's a product. It's in one term, but it's a product. This is a product. What's the easiest number to multiply by? 0. Gone, gone. Y-intercept to 7. All right, almost done. All right, there is no high school. We're going to be studying 12 functions that we graph. 10 of the 14, sorry. We will be doing 14 graphs in this course, and 12 of them are 10-second or less. That you can graph something like this in 10 seconds or less. Okay, so I'll move the 4 to the other side. I think that's the best way to write the equational line. -2, -4, -2, -4, right there, -2, -4. And I'll use the slope. Down 3 over 5 as a ratio, right? And if I go down 3, -4 becomes -1. And if I go over 5, then that becomes 3. Ooh, did I butcher that? Did something stupid here. Oh, no, it's a minus sign. Down 3 over 5. Oh, down 3 from -4. I knew this was butchered. -7. Brain getting a little tired here. There we go. Now we're good. All right, and here's your favorite mx plus b. Again, this is a product. What's the number you use for a product? 0. That's why people do 0, 9. It's easy to see. Unfortunately, it doesn't help us with the other 12 problems that we're going to learn how to graph in 10 seconds or less. So down 3 over 5, so that kind of ratio. And if I go down 3, I'm at 6. And if I go over 5, I'm at 5, 6. And I got a couple of 2 points on a line very quickly. I will tell you that this is a y equals square root of x problem. And I'm going to leave it as a challenge question and see if anybody can come in with that equation tomorrow or Monday. This is the weekend. All right, so that's done. I got it done before kids come into class. Hooray. How long did it take me? Twice as long if I wasn't talking, maybe 3 times as long. But whatever it took me a while because I had to, instead of doing it in my head, I had to write things out. Okay, hope it helps.